Okay, so we are sketching quadratics in completed square form. Completing the square tells us the turning point of a parabola. It's very useful if a parabola doesn't have roots, which we're going to look at, basically where the graph would cut the x-axis, but more importantly, it's when the turning point is not the origin in the case of kx squared. So a wee reminder on how to complete the square. You are going to half the number in front of the x, so x plus 1 squared, take off 1 squared, add 3, which gives us x plus 1 squared plus 2. And this one here, again, half the number in front, x minus 3 squared, take away 3 squared, which is 9, add 13, and that is x minus 3 squared, and that is going to be plus 4. So a wee reminder on completing the square there. Okay, the most basic quadratic is y equals kx squared. It's got a minimum turning point at 0, 0. So I'm going to draw each of these in. Okay, so there is, oops, I'll redraw that one, a wee bit dipped. Okay, there we go, 0, 0. So that's y equals x squared, 0, 0. Okay, the following parabola's got equation x plus 1 squared plus 2, and I'm telling you the turning point is at minus 1, 2. So it's going to be like that. Okay, and then the last one, y equals x minus 3 squared plus 4, is going to be along 3 up 4, which is going to go like that. And I want you to have a wee look and see if you can spot a pattern between, maybe not the top one, it's a wee bit more challenging to see, between that equation and that turning point. That equation and that turning point. So if you want to pause the video, have a wee think, and I'm going to go through it in a wee second. Okay, the link is that the numbers almost match up, but if you look at this one, when it's positive in the bracket, so I'm going to take the highlighted bit out of the way now. If you look at the number inside the bracket, so what's happened? Well, positive 1 has gone to negative 1, so the number inside the bracket is the x coordinate, but you have changed the sign. Okay, it's went from positive to negative. The y coordinate is just a number outside, so the number at the end, or outside the bracket, shall we say, is the y coordinate. So let's see if that applies for this one. Well, the number inside the bracket is negative 3, it changes to positive 3, yep, and the number outside the bracket stays the same. So, yep, that matches up, and that's the two we've got. So what we can do, without actually drawing it, we can now say, okay, the turning point is minus 1, 2, and 3, 4. So, let's have a go at some of these. Right, a mini exercise, write down the turning points of the following parabolas. Well, using that rule, the first one, the turning point is going to be minus 4, 1. This one is going to be 2, 3. This one is going to be 3 minus 1, and this one is going to be minus 5 minus 6. Right, let's put this into practice now of actually drawing and interpreting graphs. So, let's sketch this parabola. So, on your sketch, we want to see the coordinates of the turning point, which we've just been doing, and the point of intersection with the y-axis. Okay, and state the axis symmetry, so we'll talk about that as well. Right, the first one is the turning point. Okay, we know how to do that. The number inside the bracket changes, so it's negative 1. Number outside the bracket stays the same. For the y-intercept, okay, that is this bit here, is the y-intercept. What we're going to do is set x equals 0. So we have got an equation here that I'm going to say, okay, x is 0, 0 plus 1 squared plus 2. that is 1. Square it's still 1, add 2 is 3. So our y-intercept, x is 0, y is 3. And what we've got to do now is basically draw it all. So I'm going to draw coordinate axes. So x and y. Turning point, -1, 2. 0, 3. So if that's 0, 0, 3 is above there. And to finish off your question, we've got a parabola shape now. We've got this kind of shape. We know that x squared looked like that. So it is going to be this shape now with a minimum turning point. We're going to look at when we've got a negative in front of there, when it's going to be a maximum, but that's going to come in a few pages' time. So this, to finish off, is going to look like that. Obviously you're going to draw a wee bit better than that. I'm going to try another one myself. And that is your parabola. It does say the axis of symmetry. The axis of symmetry, I'm just going to tell you just now, is always x equals the x coordinate of the turning point. So our axis of symmetry, well, the x coordinate is -1, so it's going to be x equals -1. Okay. That's very similar. I want you to have a go at that one. Pause this video. I'm just going to put up a full solution after this, so